continuing on, wanted to mention a little story about a university in the north central area of the U.S. In 2010, they monitored and they saw they had about 50,000 wireless sessions a day. The university didn't grow drastically in terms of users or in terms of geographical area. In 2012, day one, they had 492,000 wireless sessions, day one. 10x fold in 2 years, number of wireless sessions. The geographic area didn't grow, which means you got a lot more sessions, a lot more people. By the way, they're now carrying over 3 devices per user. So more devices in a nice tight area. How do you actually verify or qualify that, okay, the wireless is going to handle that? And Tim McCarthy, our senior manager for TME, is going to walk through what we're doing here at Juniper to make that a real life situation.
Yeah, Bruce set that up pretty well for us. So this next section we'll go through fairly quick. Just kind of we have a test event coming up in a couple weeks that sort of a recurring thing that we do here. That's sort of the way we test some of our high density features and functionality. The timing was just off on this one. It would have been nice to give you guys a tour of what we're actually doing over there. It's coming up, but it's interesting enough, and there's some things about the test bed that are kind of cool. So we thought we'd run it by you guys, show you some of the stuff that we do. If you have any questions, feedback on things that you think vendors should be doing more testing around, things that we're not covering, things that we have good coverage on, would love to hear it. So let's see, where do we? Okay, so we go there. So Juniper does, like all vendors, we have lots of test beds that are structured a lot of different ways. We do a lot of conductive testing, all of our feature testing, system level testing, just organizations that are dedicated to to testing things in 1,000 different ways. That being said, when you guys are actually out there in the field, sometimes it may not feel like we do much testing at all when we find these things. Bugs are part of what we do here.
This picture, by the way, should make all you Apple users real happy.
Right. So.
It just goes to show what the next generation is.
That's it. It goes to show where I should have put money in a few years ago.
Means you're old then.
So what are we trying to solve with our test bed here? This is a perfect example. So we have we're talking to our customers. You guys talk to them. We talk to them. The question that they really want to know is how is this stuff going to work in my environment? We say all these things, there's all these features that sound great, but what will it do? What will it do in my space? So how do we design a test, or how do we successfully answer that question? How do we design a test that accurately covers the things that are relevant to the user experience in this particular space? So how do we build a test that will answer that question for the customers? Things are getting more complicated. This picture is a great example. Not too long ago, a bunch of laptops on a cart in an AP were, was considered an okay test. I think we've gone beyond that. Doesn't work that way anymore. We need tests that cover a broader range of features how they work in concert together. Measurement is not always going to be something like a throughput number. Measurements are now much more specifically around user experience. So is this gonna make my users happy? So I've been dying to find an opportunity to use this potato picture, and it is relevant. So hang with me for a minute. So what are we doing with this particular test? There's there's a whole host of different ways you could do high density tests for different environments. There's things like stadium applications. There's outdoor tests. There's a number of high density comes in a bunch of different flavors. So how do we narrow it down to to kind of define a test scenario that's sort of most applicable to to a large number of our customers? This particular test that we're doing here is sort of is tailored to model kind of the auditorium setting, or a high density classroom, which which works for a lot of our enterprise customers, which is relevant for sort of corporate enterprise, so in large conference room kinds of things. So that's what we're trying to do with this test bed. So as we're going through this, see in a couple slides, it's setting this thing up, building this model is sort of a non-trivial effort. There's a lot of time and energy that goes into this. So there's a lot of consumers of this data. So engineering is embedded in this, sort of learning from how the system behaves in this, so we can optimize certain features around these environments. Marketing is involved, so we can produce things like design guides and recommendations for our customers on how to do this kind of thing. But fundamentally, the whole thing is it's a QA exercise. So so Juniper's QA team, this is a structured test that we do. So being that it's QA, there's sort of a bunch of things that we factor into this that that we have to do to I guess to make it a valid QA test. So things like reproducibility are key. So automation is important. So the idea that issues that QA finds and submits into the system, want to make sure that those are reproducible, that we can fix them. Once we're fixed, we need to make sure that we can verify them. So there's sort of some testbed stability things. It needs to be the same. Issues need to be reproducible. So it all needs to be sort of work with the sort of QA process. The potato piece of this. So all of this, we realize that that no test scenario is going to be an exact model of what the customers are trying to do. So there's trade-offs. How do we build something that's going to be relevant, kind of within reason? So the potato thing, as cool as that would be, doesn't actually make that sort of
You're all
reason,
familiar with
the
that,
reason
right?
cut, right?
Okay.
$30,000 of potatoes every time we go do this test would be a bit much. So we try to build this test that's going to work, that's going to give us good, meaningful results, sort of within the constraints of what we have to work with. So what are the things that we test in this, in this environment, in this test event? There's a whole host of things that we can uniquely stress in this type of environment. So we want to pick out the ones of those that will, sort of at the outset, that will be sort of most relevant for user experience. So things like the way the system sort of automatically configures itself. So all the auto-tune functionality. How does, at boot up, how does the system configure itself in this, in a relatively dense environment? Not only sort of at boot time, how do we do channel and power allocation, but so what are sort of customer scenarios that would cause the algorithm to readjust? So I've got a huge influx of users. Somebody goes out and starts adding more access points to increase capacity. What does that do to the way we do channel and power allocations? Things like broadcast mitigation. So so as we have lots of devices in here, there's a number of features, a number of things that we'll do in the system to reduce the amount of broadcast traffic on the network. Just get rid of that the low data rate stuff. So as we use those features, as we enable those to improve overall performance, what does that do to the user experience? Are there trade-offs to be made there with how users will interact with the network? A whole collection of stuff on sort of load balancing, band steering, airtime fairness, all goes into that. Obviously huge for the aggregate performance of the system. Are we balancing clients correctly between band? Once they're in the right band, are they getting distributed correctly across across available medium? Is really what we want to do. Huh?
The load balancing, that's clients between APs?
Yes. So in this context, this is client
So
load
when
balancing.
I've looked into it in the past, and it's all from the Cisco side, I know George has done a bunch of testing on clients.
Mm-hmm.
And a lot of them, I'm not sure how other vendors do it, but I think it's status code 17 maybe, that the clients have to support in order for load balancing to work on the Cisco side, basically saying AP is busy, I'm not trying to associate. Is that the same method that's used? And have you seen? Does it,
So kind of this last bucket here is kind of the, how do we handle sort of device specific things? There's a host of mechanisms that we use to move clients between devices. The .11 association code says I'm too busy, is one of those.
Which most clients ignore.
What we tend to use more effectively is timing on certain management packets.
there seems to be more standardised support in. I think it's added to 11K. There doesn't seem to be any industry or vendor pickup that I've even seen. A whole bunch of client metrics that would be useful probably for the load balancing. If there's any support or
So there's a bunch of stuff, that has been standardized. I don't know if Steve wants to cover some of those. Is it K? Who's got the client?
anyone?
Yeah.
So Age 11K supported support for client, I guess, more data from the client in order to be able to put in with what I'm talking about at least, load balancing between.
Reporting and things like that.
Yeah.
So AP load, for example, to be able to push the clients to the appropriate AP. It's the load balancing I've seen doesn't work very well.
Yeah, so we have some load balancing. We don't have the 11K neighbor reporting right yet.
Sure.
I think we're going to see people moving there.
I'm not sure that anybody
Alliance
really does.
has this voice enterprise certification, but the unfortunate thing there is there's a lot of hard features there, and basically no vendors have stepped up to that. I think there's one certified client for voice enterprise, so we're kind of in the same boat there. That there's a lot to do, and we intend to do it, but we're not there yet.
So all tools that we can evolve to use over time.
Someone asked a question.
Huh?
Do you have little nerd knobs to control those so you can adjust those from IT guy's standpoint? I'm sure you have the ability. Are they in the interface so we can?
They're exposed.
60, 40, 35, 65, whatever.
Yep. And that's actually sort of a big part of this exercise is figuring out what is the right setting for to recommend to our customers. So in an environment that's mostly Macs, how do Macs respond at
Better than PC.
just generally, of course.
There's no environment like that anyway.
But so which of the settings is going to best influence a certain class of devices? So how do these devices respond differently to our?
So are you going to publish those results? That's really interesting to us to see what those answers are.
Sure. So we actually have there's a whole number of pieces of collateral that will come out of this.
And some of this is to give you an idea of what we're doing, and if you've got feedback, we want to hear it.
Yep. Okay.
Yeah.
Given the signal. So there's the stuff that will come out of this. We'll have some design recommendations for customers. So kind of the sort of standard dig kind of materials. This event, I know third-party tests are always viewed skeptically. Part of this event will be participated with a third-party vendor, third-party test houses coming in to help us with this. To test certain bits of it. In particular, the next two, so traffic forwarding and high availability, is kind of where we're going to do some testing around this, and where we'll have some input from a third-party test house into how those tests are designed, how we qualify the results, and then then ultimately we'll publish something out of that material as well.
Looking forward to your results.
Okay.
Is there a time frame for when all that comes out?
Probably next couple of quarters is when I expect to see it start coming out. There's a few pieces that'll trickle out over time. So some of the other things that we want to test in this environment is not only the wireless stuff, but kind of how we fit into the larger Juniper picture. So the WL components working with the EX switches, with SRX for security, with MAG for policy. So all of that's kind of tied into this test bed. This last bit is just kind of sort of how we do this, and kind of where does this happen? Just actually on the other side of that building, we can't see it from here, but is this Juniper's large auditorium structure, rough like this, seats about 3,000 people. So just for reference, that dude there is about 6'1", just to set a sense of scale. So it's a little unwieldy, but kind of the way this is organized, we design the tests so that every one of these seats has a device in it. Every seat has a row A, seat 1, so that is the user's identity. So we're doing .1x authentication to the wireless network. The identity is the seat number, so that we have a number of systems that are all sort of keyed together, so that we can identify sort of precisely which device in the testbed is exhibiting the particular behavior we're looking for. So it's surrounding kind of the seating area, if you will. We have our access points up on towers, sort of set back. There's 6 of these placed around the testbed. The idea is that for different tests, we cut down the number of access points. We can try them in different combinations, but starting with 6, kind of at the 4 corners and 2 on the edge. Roughly ceiling height is kind of how is how we provide coverage for the space. Power management, nuisance, but we're sort of stuck. So kind of earlier in the picture you saw, there's kind of main power rails that run under the floor, so we go in there and we tear up the whole building.
A lot of wires for wireless.
That's amazing how that works. So yeah, so for to address that, so that reproducibility question for QA, one of the things that we've observed over time is all of our mobile devices and laptops start doing different things when their batteries start getting low. So they start getting desperate, and then desperate usually involves turning off radios and doing weird things. So rather than try to build a test to accommodate for that, it's easier for us to just have everything plugged in. So consistent behavior out of all of the client devices sort of over time. So what that means is everything gets a plug and an extension cord. So generally one of the goals is to try to keep the clients as pristine as possible, but one of the changes that we do make to these devices is we set them so that they're always on, so they don't go to sleep while we're trying to do a test. Mentioned before, so one of the wrinkles to this test is, we book that facility in a week and a half, 2-week blocks of time. So rapid deployability becomes key. We have short windows of time, so we have to be able to set this thing up in a day and tear it down in half a day. So to deliver some of that, we it's kind of network in a box. Last time you guys were out, we had that little suitcase of equipment. This is its big brother. It's a rolling half rack. Same components, actually the nearly identical configuration. So we used to support, just it's simpler for us to use our scripts and things if the numbering is all the same. But sort of network in a box, we roll this in, we put up our APs, we do our chairs, our clients, we test, and then at the end of our window, we back it all up and disappear. Just rough topology. I mentioned, when we're testing availability of the component, which is sort of a big part of what Juniper wants to test in the solution. Not only do we test availability at the WLCs, but the testbed also gives us the opportunity to test failure of the switch infrastructure. So, so say my controllers are fine. What happens if I experience an outage in my wired network? What does that do to the wireless user experience when there's these other unrelated failures? Similarly with the with the security at the edge, so the SRX device is doing firewall. We can fail those and sort of measure the impact to the wireless users as well. Just to wrap it up, so kind of how does all this work? So, so how the testbed is a bit unwieldy. There's awful lot of moving parts. It's a complicated thing to do. So automation is pretty important. Anything that with 300 clients, anything that needs to go out and talk to all of those is a lot of work. So the whole thing is structured around sort of a common database of a Google Doc that's out there. We could share the link if anyone's interested. It's got all of the devices in the testbed, things like MAC address, IP address, platform, sort of a whole bunch of details about the device. And then we write a number of scripts that go ahead and pull that data and answer questions like, okay, I'm ready to run my test. I want to go through and sweep all my clients. Who's on the network? Is everybody using the right IP address? is the Chariot agent running. So we can do a couple of, we can pull information out of this, the central database, and use that to, to help get us ready to run our tests. Bruce mentioned SmartPass Connect at the beginning. So, how we built this thing, SmartPass Connect plays a huge part in that. So, 300 devices doing all of the wireless configuration on those, would have taken a really long time. So we use SmartPass Connect. We build our profiles of what our test bed's going to look like. It actually included 3 SSIDs. We have our .1x SSID, a PSK SSID, and an Open SSID. So just by going to the devices and starting the SmartPass Connect bootstrap process, we pull all that config down to each device. So it's consistently configured on each device. One of the SmartPass Connect features is at the end of that configuration step, it will report up device information to us. Things like, what's the driver rev, MAC address, just a number of
Social security number, blood type.
Fortunately, not yet. Yeah, just things about the device. So it reports that up to the management system, and then we actually incorporate that into that, basically into our database of information about these clients. So when we're doing some of our tests, like how well does this device respond to load balancing, we know an awful lot of details about what that device is, like almost all the way down to the driver rev.
Now,
So-
on that point, are you mixing up, different driver revs and iOS 6 and 6.1 and older stuff? I mean, are you really striving for like a broad mix of stuff, or are you not paying that much attention on the client end?
So I think we get some of that just by virtue of how the test bed is constructed. So we're the devices are generally don't upgrade them when we get them. So it's try to be as close to out of box as possible. It's devices have been acquired at different times. So I think we get some of that some of those differences just in sort of the timing of when things were added to the test bed. It's a decent mix of devices.
Not specific to the testing as such, but specific to high density. This is a question I like to ask every vendor. It's a pet peeve of mine. You guys presumably have a listen-only mode for APs. Monitor mode,
Sentry mode, sure.
Yeah. Is that can that be done per radio or only per
can.
AP?
Per radio.
Okay, good.
Oh,
So your question earlier about deploying 5 gig and 2.4, we can kill 2.4 radios and have the 5
and
gigs
that's
run.
and the reason I ask that all the time, I've been doing hospitals the last 18 months or 12 months to 18 months, a lot of hospitals, voice at 5 gig, redundancy, AP redundancy, so you've got 2 APs at NIG 67 or whatever, and then a crazy amount of code channel at 2.4 because of that. And so I've been doing Cisco. Unfortunately, Cisco can't yet do monitor mode per radio. So
Yep. So yeah, individual control over radio. Yep. So yeah, just to, I think because I'm running out of time. So the traffic generation bit of this, again, for QA, for reproducibility, for just the data that we need to collect off these systems. Chariot's not perfect, but it's industry standard. It's it's fairly easy to run at at a scale like this. So each of those endpoints has each of those devices has the Chariot endpoint installed on it. So we can coordinate that from the central console, run tests, control what's happening with that, collect results in one spot. At 300 devices, we're using the Ixia chassis to sync the traffic, just to remove. You guys are familiar with the Chariot architecture, just to remove a PC as the server component. So we offload the work of that to the chassis. Let's see, and sort of how we get a lot of the data. So do we verify that things are working right? So we have a set of sort of 6 towers. So 6 APs are active at any time. At each of those towers, we have a dedicated sniffer machine, basically set up that's attached to the wire. From that table there's scripts that will go out and start a simultaneous packet capture. So we configure the sniffer for whatever channel its tower is on. Start a capture, finish that, report the data back to the central system, merge it together, and then we can use tools like Case Pilot or the Metageek IPA stuff to do a different analysis of the data that we've collected off the system. Piece of that. So once when we're combining packet captures, timing becomes a bit of a concern. So fortunately, there's guys in Juniper on the service provider side who care an awful lot about really precise time. So we can take advantage of the precision time protocol support out of the MX80 platform. So we use that as our clock source for our packet capture system. Generates a lot of data. So we tend to do very short snapshots when the test is doing, say, a throughput analysis. Yeah, and just the last bit, some pictures. It's a labor-intensive piece of work. So we do these events every 2 or 3 months, kind of depending on availability of that facility, and it tends to be kind of an all-hands-on-deck sort of thing. Everybody comes, and there's an awful lot of running around poking clients, and A1 is down, run over there, fix it, get it back up, and run some tests.
And you do that generally in between like software releases, or what's typically your trigger for saying, hey, we've got to go do this event?
Usually availability of the facility. Which whenever it's available, we'll take it. Exactly. Yeah, it's just the size and the sort of the complexity of what we're doing. It's kind of a challenge. So, fortunately, Juniper does have a space that we can use, but a dedicated space sort of that size to leave something like that running would be a little bit more problematic to find and
How
maintain.
long does it take to set up and take down?
It takes about a day to set it up and about half a day to tear it down.
Wow, that's pretty fast.
We've done this a few times.
So is this something that is valid? I mean, when we pull and get reports out of this, is this something that your customers or you guys are looking for this type of information?
I would love to see this at Wireless Field Day 5.
Oh, there you go. That's a challenge.
If you just check with our QA department before you start the next one of these, we'll see what we can do.
I was wondering, the stuff you're talking about there, a lot of it is the actual data, analysis of the data that's being put across this, and I'm sure as RF engineers we all know that it's also really important to look at what the RF's like, especially in a high density environment where there's lots of co-channel interference and that. Are you using tools like MetaGeek's tools to be able to look for that?
We do. So Channelizer, is part of the test bed. We deployed more selectively on a per channel basis. I don't have 6 of them or 12 of them, so there's just kind of can't monitor all of the channels at the same time. But it's definitely used to sweep ahead of time to monitor particular channels during test. But it has to be really more of a sort of a targeted view of it.
Yeah, because I know that's one of the most difficult things with high density designs is making sure you're not falling all over each other with the channels you're actually deploying. And that's also a good test of what your automatic channel capabilities are to see whether that co-channel interference is coming up from there.
Sure. So while the tests are running, Channelizer would give us a view of that, and then some of that we could glean after the fact from characteristics in the packet captures, excessive retransmits, if there's funny delays in there.
Okay, so you're looking for high levels of retransmits as well.
As one cue that there's something we need to go back and look for, sort of specifically look for during one of the traffic runs.
So do you have any results from the previous runs of this test?
We have tons of results. Nothing is captured here. I wasn't preparing results today.
Oh, I mean, published.
No. This is all, just internal stuff.